Hello, welcome to 7.6 Graphing Root Functions. Today we're going to be graphing square root functions and cubed root functions. We'll see some similarities and some differences between them. But first let's start off with the parent function for square roots, which is the inverse of x squared. If you remember, f of x equal to x squared, that's a parabola shape where we have it facing upward. So when we're doing the inverse, we're going to get something similar, but remember that with inverse functions, what we do is we switch the x and the y tables. So what we used to use for our points in an x squared, like a parabola, quadratic equation, we did 0, 1, 4, 9. Now we're going to put those in our x column, 0, 1, 4, 9, because we're going to switch the x and the y tables. And then what we had in the x column was 0, 1, 2, 3, which makes sense because if I take 1, 4, or 9, those are all perfect squares, so that when I plug them into the function, they break down to square roots. All right, so now when we graph this, we're going to see some things that change. So 0, 0 is still the origin. That's this point here. Change my color. And then we got 1, 1, over 1, up 1, 4, 2 is over 4, up 2, and then 9, 3 is over 9, up 3 right here. Now if I connect those, you have to imagine that if I were to continue this below, like if I were to go down here, I would still get a parabola shape, but because that wouldn't pass the vertical line test, I can only graph half of this. I'm going to go back here. So this is the only part of the shape that we're going to see. Our domain is what are the x values that we're allowed to put in. In the previous two lessons, we talked about the domain and like the restrictions. We know that for square root functions, we can't have any negatives. So we are going to start this at 0, which is the point that we see here, the very first point in the x value, and everything gets bigger from there. So we're going to say x is greater than or equal to 0. For the range, because it's going up, there's nothing going down. We haven't talked about range as much, but in this case, we also have a limited range. Since it would continue to go up and up and up forever and ever, that means that our y value is greater than or equal to 0. And these 2 points just come from our starting point, which was 0, 0 in this case. That's going to change in a few examples here that we'll see in just a minute. Now the parent function for cubed roots is a little different. It's the inverse of f of x cubed. And that table used to be where we would plug in negative 2, negative 1, 0, 1, 2, and we'd get out negative 8, negative 1, 0, 1, 8. We did this back when we were graphing polynomials. But now what I'm going to do is I'm going to take those same values, I'm just going to reverse the order since this is the inverse. So the negative 8, negative 1, 0, 1, and 8 go on the left side, and then the other points are going to go on the y column. Now when I graph these, negative 8, negative 2, that's left 8 down 2 right here. Negative 1, 0, 0, 1, 1, and then over 8, up 2 is right here. We do still get a shape. It's kind of like a snake shape, but it continues, and it used to look something like this when we graphed this function here, but I shouldn't have used an arrow there. This is what we're getting. So our domain this time, it's continuing in both directions forever and ever. So the domain here is all real numbers, which we can write as x is an element of the real numbers, or if you want to use that set notation, goes from negative infinity to positive infinity. This just means that we can plug in any x values, there's no restrictions. And we talked about that with cubed root functions or any odd root functions. They don't have restrictions because we're allowed to put negative numbers inside of the radical. For the range, same exact thing, except we're talking about the y values. So we're going to say that y is an element of the real numbers, and it goes from negative infinity to positive infinity. This is going to be the case for all cubed root functions. Both the domain and the range are non-restricted, so we are going to be able to put real numbers for both. Here's some function transformations if you want to look at this. We're going to be talking about h and k again. K is our vertical shift, either up or down, depending on if we're adding or subtracting. H, is the horizontal shift, and that's going to move it left and right, depending on if we're adding or subtracting. Remember, because we have it in the parentheses here, it's going to be the opposite of what we think. So I like to just note that. And then we're going to be talking about the vertical stretch or shrink. We've seen that before, as well as some reflections if we have a negative. So let's start off with some general equations. A is going to be our vertical stretch slash shrink. And then our H and K, that is going to be our starting point. It's not so much the vertex anymore because it's not like a turning point. So we're going to think of it as just our starting point. Then the domain for this is dependent upon the H value. Whatever we're subtracting from the X, that's what's going to determine the domain. So the domain has to be greater than or equal to whatever the H value is. Same thing for the range. If we're looking at that here, that is going to be y greater than or equal to the k value, depending on if it's opening up or down. Okay, so the range can also go less than or equal to if we have a negative a value. The a value won't change the h though, so that's one thing to keep in mind. All right, now a quick sketch of this. We already talked about the points, but 0, 1, 4, and 9. And then our y values would be 0, 1, 2, 3. It's just the same points we used before in reverse order. So 2 and 9, 3. So this is our sketch that we saw up above. Now when we're talking about the cubed root function, the a value still means the same thing. I'm just going to copy this over here. So it is still the vertical stretch or shrink. It is still going to be the starting point, but in this case, I shouldn't actually call it the starting point. Think of it more as your turning point. And it's going to be directly in the middle. So if we look back at this graph here, the point that we were talking about was 0, 0. So let me just highlight that here. This would be our H and K point. That has to do with the shift. So for the domain, it's all real numbers. We don't have to worry about that at all. And then our range is going to be the y is an element of real numbers. And for every single cubic function that you do, your domain and your range are both going to be those answers. You have to be more considerate when you're talking about it for the square roots. So then the points we're going to use are the same ones we listed above, -8, -1, 0, 1, 8, and then -2, -1, 0, 1, 2. We're going to use those same ones every time. And we're going to get that kind of like snake shape. Depending on if it's opening up or down. Because the a value will determine which direction it's going to open. I also should have listed that. So, direction. All right, here's our first graph. We have 3 times the square root of x minus 2. Our h and k in this instance, because there's no term inside of the square root with x, this is one thing you have to be considerate of. X is alone in there, so this minus 2 is not affecting our domain at all. That's actually the k value here. The h value, since we don't see one, we're going to assume it's 0. So 0, -2 is going to be our starting point. So that's right here. When you describe the transformations, because our value is 3, our a value is 3, that would be a vertical stretch. If we had something that was like a fraction less than 1, like 1/2 or 1/3, even -1/2 or -1/3, we would think of that as a shrink. But if it's greater than 1, we're going to think of it as a stretch. So we're going to write vertical stretch, and we're also going to put that it is down 2. It's shifted down 2. And if you wanted to write like a vertical shift down 2, you can also be more specific. But now for the x values here, since this is a square root, we are going to go 0, 1, 4, 9, 0, 1, 2, 3, and our a value is 3, so we do want to multiply that by everything in the y column. So 0, 3, 6, 9. And then I'm going to cross out the middle one. So 0, 0 is our starting point, which is actually at 0, negative 2. This is the point that we now consider our 0, 0. So from that point, I'm going to go over 1, up 3. Then I'm going to go over 4. 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. And then over 9, up 9. It's right here. So we do get like a really, it's stretched out. If this had been a parabola, it would be like a really wide parabola. Now our domain for this one, since our starting h value was at 0, it's going to be x is greater than or equal to 0. The range is going up from this point. It's getting bigger, so our range is going to be y greater than or equal to, and our starting y value there is negative 2. It's the k value. Okay, so here we're going to do one more of those. Actually, this is the cube root function we're going to graph. So h and k here is at negative 2. Remember that it's the opposite of this, so this is our h. And we can assume that the k value is 0 here since we don't have a number outside. So negative 2, 0 would be our starting point, which is right here. That's actually going to be the middle because this is a cubed root. So that's going to be like the 0, 0 was on the parent function. Now for transformations, we do have a reflection because it's negative. So it's a reflection. And it's also a vertical shrink this time because it's a value, the absolute value of negative 1/2 is less than 1. So vertical shrink, and then we can also say that it goes left 2 units. Now, be careful when you're jumping back and forth from square roots to cubed roots. So our cubed root is going to be negative 8, negative 1, 0, 1, 2, or 1, 8, and then it's going to be negative 2, negative 1, 0, 1, 2. Now, negative 1/2 is going to multiply with everything in that column. So this is where you have to also be careful. 2 negatives are going to make a positive for your first value. So it's negative 8, 1. Then this would be 0.5, 0. Now it's going to shift back to negative and negative 1 here. So when you're graphing these, you're graphing them from the point negative 2, 0, because that's your new h and k. So negative 8, 1 would go left 8, up 1 right here would be our point for that. Negative 1.5 is going to be left 1, up 0.5 from the h and k. And then 1, negative 0.5 is right here. And then 8, negative 1, 1, 2, 3, 4, 5, 6, 7, 8. And then down 1 is right there. So this is a shrunken version of it. It's a little bit thinner, which makes sense when we talk about vertical shrink. And then the domain for this one's nice and easy. X is an element of the real numbers. Y is an element of the real numbers every time for these cubic ones because we have no restrictions. And you can put the set notation if you want. Okay, now just a couple more here. Graph y equal to negative 2 square root of x plus 3 plus 5. So our h and k here, it would be negative 3. This is our h, this is our k, and then our k value would be 5. So negative 3, 5 is left 3, 1, 2, 3, 4, 5, right up here. Transformations, it is a reflection. It's also a stretch. And then it is to the left 3 and up 5. Okay, back to square root. So we're 0, 1, 4, 9, 0, 1, 2, 3. We have a negative value here, so it's 0, negative 2, negative 4, and negative 6 this time. So I'm going to cross those out. Now when I graph these, I'm graphing 0, 0. This is my h and k value. So I'm going to go over 1, down 2, over 4, down 4, 1, 2, 3, 4 right there, and then over 9, down 6. Right here. Okay, now I'm going to connect these. Notice that this time they're going down. That's not going to affect our domain because the domain is still moving left to right. It's still getting bigger technically because these x values are increasing as we go that direction. So we're going to say x is greater than or equal to -3 is what would make our square root equal to 0. So we want our values to be greater than or equal to -3. But because the range is going down this time, our graph is going down, that does affect the range, and that means that y is going to be less than or equal to 5 because it's getting smaller. As it goes down, those y values get lower. Okay. On to the last example here. Another cubed root one. Our h and k is 1, -3. Opposite of this, k stays the same. And then this one would have a vertical stretch. I think I forgot to write vertical stretch last time, but stretch is the most important word here. Okay, vertical stretch, and then it looks like we are going right 1, down 3. No reflection. Back to the cubed root, -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. Our a value is 2, so we're just doubling everything. So -4, -2, 0, 2, and 4. And it didn't leave us with a graph, but that's fine. You get the idea for this one. The domain would be all real numbers, and same for the range, because there's no restrictions on a cubed root. And that's it for this one.